In this section, we're going to take a look at the RemoveAt method. So I bet you could guess what this thing is supposed to do. We're going to call RemoveAt with some index of the particular node that we want to remove. And our job is to simply remove that node. So the first thing to do is to recognize exactly what it would mean to remove a node in the middle of some given chain. So in this diagram over here, let's say that given this chain, we want to remove the element at index 1. Again, recall that the first element inside of a linked list will always have an index of 0. So this is 0. This right here would be the element at index 1. So our goal would be to remove this element. To remove that element, all we really have to do is find the previous node in the chain and update its next reference to now skip over that one. So we would end up with something that looks a little bit like this. Now, in theory, that node might still exist in memory, might still be there, but as far as our linked list is concerned, it doesn't exist anymore. Because if we were to iterate through our linked list now, we would go from green directly over to red and completely skip over blue. Now this problem, RemoveAt, is going to be a little bit more challenging because we need to consider many different edge cases. At this point in time, throughout all the methods we've put together, we've kind of assumed that a developer using our linked list class might accidentally make some type of mistake. Like they might try to insert an element at an index above what our current index is, or they might try to remove the first node in a linked list that is completely empty. And I want to continue that same kind of logic with this RemoveAt method as well. So I want to make sure that our linked list is not going to crash if we call RemoveAt when, say, there are no elements inside the linked list. Or if we say that we want to remove the element at index 1, but there's only a single element in the linked list. I want to make sure that we do not crash in this case as well. And then if we try to remove the element at index 10, when there's only 3 elements in here, I want to make sure that we also don't crash in this case too. So there's several edge cases that we need to be thinking about. Now let's check out our test file really quickly. So inside the test.js file, I'll find the describe block for RemoveAt, which is at line 167 or so. And as usual, remove the .skip on there. So notice that there are tests on here to catch many different edge cases. So it doesn't crash if we call RemoveAt on an empty list. RemoveAt doesn't crash if we pass in an index that is out of bounds of the linked list. And then it should be able to delete the first node. It should be able to delete some middle node. And then finally, it should also be able to delete the last node on the linked list. All these different cases are absolute edge cases. These are different scenarios that you have to think about with your given solution. So this really is one that might be a little bit more tricky than it seems at first glance. Now, if you want, you can stick around for another moment and I'll give you one possible solution, or not a solution, but I'll give you kind of guidance towards one possible solution. So here's one way of solving it. Let's say that we want to remove the node at index 1. Our previous remove method that we put together, the one remove last, you'll recall, we had a pointer to the first node and then the second node, and then we kind of advanced those along until we found some node that had a reference of null for its next value. And you might be thinking that we could use that same type of approach where we have 2 of these little pointers pointing at node 1 and node 2, and then we advance them along until we find the given index. Now there's just one little issue with that solution. And the issue is that it doesn't really handle edge cases very eloquently. Like it doesn't really handle the case in which we want to delete the first element very well without you writing a very discrete if statement to handle that case. So you could definitely take 2 references, like a reference to some previous element and then some current element, and iterate through the chain. You could definitely do that. You just need to be aware that you're going to have to write a lot of code to handle those edge cases nicely. So here's one possible solution. One possible solution is to reuse the getAt method that we just put together. So remember, we just did getAt 2 seconds ago, and that retrieves the element at some particular index. Now, rather than calling getAt with the index that we're trying to retrieve, we could call getAt and try to retrieve the element right before the given index. So let's say that we're trying to remove the element at index 1. We could call getAt with an argument of 0, and that would give us a reference to green right here. Then we could update the next property on this thing to look over to red, like so. So again, just like we spoke about previously, reusing methods in an interview setting is the best thing in the world because it shows that you know about code reuse and you can effectively reuse your code. And it also allows you to come to solutions that are dramatically more straightforward than other complicated ones might be. Now, one thing I want to throw out there is that even with this situation right here, there are some corner cases that you have to check. Okay, so there still will be some corner cases. And I'll let you figure those out and kind of investigate what those might be. Okay, so go ahead and give it a shot. Personally, I really recommend you try reusing the getAt method, but it's always up to you. If you can think of a better solution, then certainly go for it. So with that in mind, let's take a quick break and talk about a solution in the next video.